Hi there. So today we're going to learn about application of differentiation question. Suppose I have a diagram which shows a right circular cone with base radius 4 and height 12. Then water leaks through the cone at a rate of 2 cm cube per second. Then we are told show that the volume of water in the cone is V equal to 1 over 27 blah blah blah, and then we are told find the rate. So this is our diagram. Radius is 4, height is 12, that's the water. We have height is 4 and radius r. Now we are told to show that the volume of water in the cup is that. So how do we do that? Well, we start off by saying that and applying the volume formula, which is 1 over 3 pi r square h, something we all know from E-maths. But then if you notice the formula carefully, here we have in terms of r, but the formula don't have any r at all, the formula given to us. So it means that we need to make some sort of substitution. I don't know what, but we need to make some sort of substitution. So let's see what we can get from the diagram. Do you notice anything? Suppose I extend that line. Let's see what we get if you extend the line. Hey, do you see it looks like a triangle? Yes, we can use the property of similar triangles to help us find the substitution. So r over 4 is h over 12. Then with simple cancellation and manipulation, we get r is equal to h over 3. Then we just sub in this value, plug it into the volume we have found. So we get something like 1 over 3 pi, sub in the value of r, which is h over 3 whole square h. Then with a bit of simplification, we get 1 over 3 pi h square 9 times h, which simplifies to give us 1 over 27 pi h cube. And we have just proved the first question, and we have just earned ourselves 3 marks. It's just as simple as that. See, we have done the first part. 3 simple easy marks. So let's go on to the second part, shall we? In the second part, they say find the rate of change of h when h is equal to 4, leaving your answers in terms of pi. So they gave us an information, but the information here is that we need to find the rate of change at the point when h is equal to 4. So how do we do that? Let's see. So number 2, we know that dh over dt is equal to 2 cm cube per second. This is given in the question, but is it positive or negative? It's negative. Why? Because water is leaking. When it is leaking, the volume decreases, so it is a decreasing function. That is a very important point. It must be negative. Then we have another thing is, we know we are going to differentiate. It should be simple enough. You differentiate dv over dh using that formula. So if you differentiate, you keep the constant term like that, you get 1 over 27 pi, you bring the 3 down, then you subtract the 3 minus 1, and you just do a bit of simplification. You get something like 1 over 9 pi h square. Simple enough. That was just simple differentiation. But we are not done there yet. We still have to find the rate of change of h. So the formula, which you should all know, which is the connected rate of change, is dv over dt is equal to dv over dh times dh over dt. See the pattern, don't confuse yourselves with that. We know that dv over dh is this formula, and it occurs when h is equal to 4. So we just sub in 4 into the dv over dh equation, and that gives us 1 over 9 pi, sub in 4, and then dh over dt, which we don't know and we are required to find, and we know that dv over dt is minus 2, and then you just manipulate, you'll get your answer as dh over dt is equal to minus 9 over 8 pi cm per second. So one of the key point to note here, and we got an answer. So the key point to note here is that they want the answers in terms of pi. That's what the question say. So don't go and evaluate, just leave it in terms of pi. Also remember the units. That is very important. So thank you.